Hello everyone, today in this video we are going to discuss the rules to draw the image formed by the spherical mirrors. So after watching this video you should be able to state and apply all the rules. So as we all know the curved mirrors are called spherical mirrors because they are a part of sphere. So if you paint the outer side you'll get a concave mirror, and if you paint the inner side you'll get a convex mirror. Concave mirror is curved inward and convex mirror is curved outward. So this is a concave mirror and this is the focus. Focus is a point in a principal axis where rays parallel to principal axis meet after the reflection. So concave mirror has a focus in front of the mirror, and this is convex mirror. Its reflecting part is curved outward and it is a diverging mirror, and the point from which the parallel rays get diverged is called the focus of a convex mirror, and the focus of convex is at the back of the mirror. We call it virtual focus because the back side is called virtual side of the mirror. These are the parts of spherical mirror. So this is the mirror and this is the imaginary sphere. We have center of curvature, we have pole out here, and this line is principal axis. Now we will draw a concave mirror. So in reality the concave mirror look like this, but we don't draw the concave mirror like this. So we'll draw a mirror like this because it will make our diagram easier. So this is the reflecting part and these dots are the back side of the mirror or painted side part. So this is a concave mirror having reflecting side curved inward. So I'll draw a pole out here. Now I'll put one scale. I'll draw another dot and that will be your focus, and at the equal distance I'll draw another dot and that will be our center of curvature. So this is how we draw a concave mirror. So now let's talk about the rules. So when we send a parallel ray to a concave mirror, it passes through focus. So next ray, it is also passing through focus, and one more ray, it is also passing through focus. So the rule number 1 is a ray going parallel to the principal axis will pass through the focus, and this is rule number 2. Now if you send the ray through focus, it becomes parallel to the principal axis. So this is opposite to the first rule. One more time, it is going through focus, it becomes parallel. One more ray, so it's parallel. So incident ray that is going through focus become parallel after reflection. Rule number 2 and rule number 1 are opposite to each other. And now rule number 3. So if you send a ray through center of curvature, it comes back through the same path. One more time, so it comes back through the same point. So if you send through this point, this also going through center of curvature, it will come back through the same path. So a ray passing through the center of curvature retrace its path. Retrace means coming back through the same path. Now we'll discuss why the ray passing through center of curvature retrace its path. So if you draw a tangent out here, we can see this as a circle and this is a tangent, and we know a radius makes 90 degree with the tangent. So this picture is similar to this picture because from here to here is the radius and this is the tangent. So that means here the angle is 90 degrees. So out here the angle will be 90 degree. And we already know when the ray makes 90 degree with the mirror, it goes back through the same path. So that means it should go back through the same path like this. So it goes through the same path. So as an answer we have to write it is a case of normal incidence, or we have to say the ray going through the normal comes back through the normal. So this is the answer. We can say a ray passing through the center of curvature of a concave mirror retraces its path after reflection because it falls normally on the mirror, or we can say angle I or and angle R is 0. That means going through the same path, coming through the same path. This is like this. So this is the answer. So now rule number 4. a ray going obliquely to the pole, obliquely means making some angle, will get reflected obliquely following the laws of reflection. So this angle and this angle should be equal. So for this also it will get reflected obliquely by making the same angle, and for this also it gets reflected obliquely by making the same angle. So this is rule number 4. A ray falling obliquely on the pole of a concave mirror is reflected obliquely following the laws of reflection. So this angle and this angle will be equal. So these are all the rules together. So the first one is ray going parallel will pass through focus. Second one is passing through focus will become parallel. Third one, ray going through center of curvature retrace its path, because this is the case of normal incidence. And rule number 4, ray going to the pole obliquely gets reflected obliquely following the laws of reflection. Now let's see the rule for convex. So to draw convex, we'll draw the same diagram, straight line, and we'll bend the ends another side and we'll put the dot. Now you can see the reflected part is curved outward. Now we'll mark pole. Now we'll keep a scale, and this time the focus and center of curvature is at the back side. So we'll put one dot as focus and at equal distance we draw another dot, and that will be your center of curvature. So this is a convex mirror. Now let's discuss the rules. A ray going parallel to the principal axis will diverge from focus. So let me tell you how to draw this. So we'll draw a parallel line and we'll draw a dotted line from focus to our incident ray. Then we continue this line as a ray. So this is how we draw the. So next, so it's going parallel, again it will diverge from focus. So I'll draw a line from focus and I'll continue this ray. So one more time. So this is the parallel ray. I'll draw one line from the focus and I'll continue this line as a ray. So a ray going parallel will diverge from focus. So this is the rule number 1. Now rule number 2, a ray going towards the focus of convex mirror will become parallel to principal axis after the reflection. So see, this ray has become parallel after the reflection. So in order to draw that, we'll draw dotted line till focus, and from here we'll draw a parallel line. So similarly for this ray also, it is going towards the focus, so it will become parallel. So one more time, it is going towards the focus, so it becomes parallel. So rule number 1 and rule number 2 are opposite to each other. So this is the rule. So ray going towards the focus will become parallel after the reflection. So now rule number 3, a ray going towards the center of curvature retrace its path. So it is going towards the center of curvature, so it should go back from the same path. So in order to draw that, we have to draw dotted line to show the ray is going towards the center of curvature. Then only I can draw the reflected ray. So one more diagram. So I'll just retrace the path. So one more time, it is going towards the center of curvature, so it should go back from the same path. So rule number 3 says a ray going towards the center of curvature retrace its path, and the reason we have already discussed in concave. So the reason is the ray falls normally on the mirror, or we can say angle I is equal to angle R is equal to 0 degree. And rule number 4, a ray going obliquely to the pole of a convex mirror will get reflected obliquely following the laws of reflection. So this angle and this angle should be equal. So for this also it will get reflected obliquely, and for this ray also it is getting reflected back obliquely. So this is rule number 4. Now these are all the rules together. You can pause the video and copy the notes. So now one more thing I want to add is, this is a concave mirror and a ray is going parallel. So according to rule number 1, it should go through focus after the reflection, and if you draw one line from center of curvature, that time this angle will be angle I and this angle will be angle R. So the ray going through the center of curvature to the mirror is the normal. Similarly, out here you can see a ray is going parallel and it is getting diverged from the focus, and if you draw a line from center of curvature, it will act as a normal. So this angle is angle of incidence and this angle is angle of. I think this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.